All right, let's take a look at question number 2. So for number 2, we have to solve the system negative 4x plus 4y minus 5z equals negative 3, and then negative 2x plus y minus 2z equals negative 27, and then the third equation, negative 2x plus 5y minus 4z equals 8. All right, so we're going to use the steps that we outlined before we started at number 1. So the steps, first of all, involves creating a system of 2 by 2 equations. So let's label this to keep our work organized. This is equation 1, the first one, the second equation 2, and the third equation number 3. This is a 3 by 3 because you have 3 variables and 3 equations, all right? So what we're going to do is reduce it to a 2 by 2 by eliminating a variable. Now, whichever variable has a coefficient of 1, that equation and that variable can be used to create our 2 by 2 system by combining it linearly with the other 2 equations. If you look at the x's here, none of the coefficients of the x's is 1 in all 3 equations. If you look at the y's, wait a minute, this y has a coefficient of 1. So this looks like a good variable to eliminate. So our goal is to eliminate y by combining 2 with 1 and combining 2 with 3. Okay? So let's go ahead and set this up from 1 and 2. We're going to eliminate y. Okay, so let's go ahead and set up equation 1 and 2. Equation 1 is negative 4x plus 4y minus 5z equals negative 3. Equation 2 is negative 2x plus y minus 2z equals negative 27. Okay, so to eliminate y, we want to create opposites. Okay, so the equation 1 has 4, positive 4 as its coefficient. So the opposite of positive 4 is negative 4. So what we'll do is we're going to multiply equation 2 by that value, negative 4. So that's going to yield, the first equation stays the same, negative 4x plus 4y minus 5z equals negative 3. And the second equation becomes 8x minus 4y plus 8z equals 108, positive 108. Okay? All right, now you notice that the the y's are opposites of each other, so that's excellent. So let's combine it. When we combine the x's, we'll have a positive 4x. The y's add up to 0, plus 3z equals positive 105. Let's call this equation number 4. All right, we're still on our quest to eliminate y and have a 2 by 2 system with just x and z. So what we're going to do now is we're going to shift our attention to equations 2 and 3, combine them together and eliminate y again. Okay, so let's write down what we're going to do. From 2 and 3, we're going to eliminate y again. All right, so let's go ahead and set it up. From equation 2, we have negative 2x plus y minus 2z equals negative 27 equals negative 27. This is equation 2. And in equation 3, we have negative 2x plus 5y minus 4z equals 8. All right, so we want to eliminate y, we want to create opposites. This is 5. The opposite of 5 is negative 5. So by simply multiplying equation 2 by -5. We'll have opposites for the x's, for the y's, and then we can simply eliminate by combination. All right, so let's distribute the -5 to equation 2, so that yields positive 10x minus 5y plus 10z equals positive 135. And then equation 3 stays the same, -2x plus 5y minus 4z equals 8. Now we have opposites with the y, so we can simply combine the two equations to eliminate y. So let's go ahead and do that. If we add the two equations together, we have 8x. This adds up to 0. And then we have plus 6z equals 143. All right, so this is equation number 5. We now have our 2x2 equations. We're going to combine them together. So let's write down what we're about to do. We're going to form a system with 4 and 5. Equation 4 and 5. All right, so our new system of equations we're going to solve are, let's see what they are, 4x plus 3z equals 105, and 8x plus 6z equals 143. So what we did in essence is we simplified a complex problem into a much simpler case, something that's more manageable using tools that we learned in Algebra 1. And then we'll use a solution here to find what y is, assuming there are solutions, okay? So now we have this system of equations. What we're going to do next is solve this by elimination. So we're going to either eliminate the x or the y's, or the z's, sorry. None of them have a coefficient of 1, so we don't have an easy time here. So we'll just basically look for the variable that is easiest to find the LCD, okay? Or one is a multiple of the other. So if we inspect the x's, you notice that 4 is a multiple of 8. The LCD of these two numbers is 8, okay? So it's easy to eliminate x. If you look at the z's, we have the same situation here too. 3 times 2 is 6. This is a multiple of that, so z will be easy to eliminate. In this situation, it doesn't matter which variable you choose to eliminate. They are both equally easy to eliminate, okay? All right, so let's go ahead and eliminate the x's by creating opposites here. Since 4 is a factor of 8, we just simply multiply 4 by the number that makes it become -8, okay? And that number is -2. So let's distribute -2 to equation number 4. If we do that, we're going to have -8x minus 6z equals -105. No, that's not right. We have to multiply 105 by 2 also, by -2 to be specific. So if you multiply 105 by 2, you have -210. All right, now let's equation number 5 stays the same. It's still 8x plus 6z. 6z equals 143. Okay, so let's go ahead and eliminate the x's, and that will help us determine what z is. So if we add this, this goes to 0. And then if you add this, that goes to 0 also. And then -210 plus 143 is -67. Let's check the, yeah, okay. So it's a -67. So what is this? This is a false statement, okay? This is a false statement. Now remember the instructions we went over before we started problem number 1. Anytime you have a false statement, you have no solutions. Okay, so no solutions. So what does this look like graphically? Let's take a look at the graph of this situation and see if we can deepen our understanding of what this answer means. All right, so let's go ahead and graph the 3 equations. So the first equation, there you have it. And then equation number 2, there you have it. And then the third equation, bam. All right, so what you're seeing is the intersection. You see that they do not intersect at a point, okay? The first equation and its second equation intersects on a line, and then equations 2 and 3 somewhere here, and equations 1 and 3 somewhere here. So their intersection is not at a point. All right, so what does this mean? If they do not intersect at a point, then there are no solutions. All right, so this basically happens forever. Let me rotate it a little bit. So you see how that looks right there? So the intersection is not at a point. It's 3 distinct lines, and they never intersect at a point. So this basically helps us to see what a situation where you have no solutions. All right. Okay, let's go ahead and take a look at the last example, example 3. All right, let's take a look at so for number 3, we have the system 3r minus 6s minus t equals 13. And then we have 3r minus 3s plus t equals -4. And then for the third equation, we have 5r, actually -5r plus 4s minus 5t equals 15. Okay, so step number 1 is to reduce our system of 3x3 equations into a 2x2 system. Let's label our equations 1, 2, and 3 to organize our elimination process. So we seek to eliminate either the r's, s's, or t's. Okay, now let's look at all the r's. Anyone with a coefficient of 1, that's easy to eliminate. We don't have that with the r's. Let's look at the s's, none. The t's, we have 2 of them. So we're gonna favor the positive one, okay? It could be negative or positive, it doesn't really matter, but if you have a type, you can just pick one. All right, so I like to pick the positive t, okay? So since we have a coefficient of t here is 1, so that's the easiest to eliminate. You can eliminate anything you want, but I'm trying to be efficient here, make the best use of the situation we have. Okay, so since this is our target 2, we're going to combine 1 and 2 and eliminate t. Let's write that down. From 1 and 2, we're going to eliminate t. Okay? So let's set it up. Equation 1, we have 3r minus 6s minus t equals 13. Equation 2, we have 3r minus 3s plus t equals -4. We want to create opposites, but guess what? We already have opposites here. So we don't have to multiply or carry out any multiplication to create opposites since we already have them. So we'll simply combine these 2 equations. We'll have 6r, combine these 2 minus 9s equals 9. We'll call this equation number 4. First equation in our 2x2 system. Now we're going to take 2 and 3 and eliminate t again. So from 2 and 3, eliminate t. Okay? So let's go ahead and write them down. We have 3r minus 3s plus t equals -4. That's equation 2. Equation 3, -5r plus 4s minus 5t equals 15. Okay, so we want to create opposites with the t's so we can eliminate them by combination. So the opposite of -5 is +5. So we're going to go ahead and multiply equation 2 by +5 so the t's can be opposites. So that is going to yield 15r minus 15s plus 5t equals -20. Equation 3 remains unchanged. 5r, actually -5r plus 4s minus 5t is equal to 15. Now that we have opposites with the t's, we can go ahead and combine them to eliminate t. So if we combine it, we'll have 10r minus 11s is equal to negative 5. This is equation 5, the second equation in our 2x2 system. Okay, so let's go ahead and set up our 2x2 system. So we have we're going to form a system, with equations 4 and 5. That will help us find out the values of r and s if they exist, and then we'll find the final one, t, using one of the original equations. All right, so let's go ahead and set them up next to each other so we can solve by elimination again. So equation 4 is 6r minus 9s equals 9, and then equation 5 is 10r minus 11s equals negative 5. Okay, so what we're going to do now is pick the variable we want to eliminate. All right, we don't have any ones with the r's or the s's, so we don't have an easy case here. So what we're going to do now is pick one to eliminate. Look at these two. I want to eliminate the r's, so what I'll do is I'll basically find the LCD of these two coefficients. Okay, so what is the LCD of 6 and 10? What is the smallest number that these two can go into? The LCD is 30. Okay, if I wanted to eliminate the s's, the LCD of 9 and 11, since their co-prime is 99, so that will be my target value. So what does this LCD do? I'm going to make one of the equations the LCD, one of the coefficients of r the LCD, and the other coefficient of r will be the opposite of the LCD. Okay, so let's make the first equation, equation 4, the opposite of the LCD. So what do we do? What do I multiply equation 4 by to get negative 30? Negative 5 will suffice. And then equation 2, what do I multiply equation 2 by to get the LCD 30? Just multiply it by 3. Okay? All right, so let's go ahead and do that. We're going to now have, let's see, negative 30r plus 45s equals negative 45. And then for the next equation, we'll have positive 30r minus 11s equals negative 15. Negative 15. Okay? All right, now you notice that our r's are opposites, which is exactly what we want. When we combine the two equations, we'll have this adds up to 0, and this becomes, let's see, what do we have here? All right, so let's go ahead and combine them. We're going to have, let's see, this becomes 45 minus 33 is 12. 12s equals negative 60. And then to get s by itself, you divide both sides by 12. And then you have the value of s as negative 5. All right, so that's the value of s. Now we can plug the value of s into 4 or 5 to get the value of r. So let's, how about we plug it into 5? Okay, so what I'm going to do is I'm going to substitute negative 5 for s in equation 5 with the goal of getting what r is. Okay, so let's go ahead and do that. We have 10r minus 11. Instead of s, I'm going to put in its value, negative 5. Okay, negative 5 equals negative 5. If you simplify this, you have 10r minus, actually minus times minus is a plus, so plus 55 equals negative 5. And then subtract 55 from both sides, we have 10r equals negative 60. Divide both sides by 10, r equals negative 6. Okay, now to finish this off, we'll simply plug in these two results into any equation in the original 3x3 system to get t isolated. Okay, I like to pick equation 2 since the coefficient is positive t, so that's one less step to bother about. Okay, so I'm going to substitute the two answers I got into equation number 2. So substitute -5 for s and -6 for r in equation 2. All right, so if we do that, we're going to have 3 times -6 minus 3 times -5 for s plus t equals 4. All right, let's go ahead and finish this off. We'll simplify it. We'll have -18 plus 15 plus t equals 4. Combine these two, you have -3 plus t equals 4. And then the original equation had a -4 there, so let's not forget that. Negative. All right, and then we add 3 to both sides, and then we have t equals -4 plus 3, which is -1. All right, so our solution as an ordered triple is -6 for r, -5 for s, and -1 for t. So this basically helps us to see that the three planes intersect at a point. All right, so let's take a look at the graph. So let's grab the first equation. There goes the first plane, the first equation. Let's graph the second equation, represented by this plane. And then the third equation, represented by that plane there. So you see that the three planes intersect at a point. Can you see where the solution is? Well, to help you really see it, let's go ahead and graph the point. All right, so let's go ahead and graph the three equations. So there goes the first graph. This equation represents this graph plane represents the first equation. Second equation represented by the green plane. And then the third equation represented by the other plane, okay? So there you see that the three planes intersect at a point. Do you see what that point is? Well, the point is somewhere right here. Let's go ahead and graph the point so that we can be certain that our solution is in fact correct, okay? So let's add a point. The solution that we got is -6, -5, and -1. So let's graph it and see if it's correct. Let's make it, what color should we make it? Let's make it blue. Bam, you see that? You see that? The point is located at the intersection of all three planes. So what that means is that the coordinates of that point satisfies all three equations, and this is a graphical illustration that our answer is in fact correct. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to our channel by clicking our subscription link. Do post a comment to let us know what you think about this presentation. Thanks again for watching, and have a wonderful day.